Hi everyone, my name is Peter. Welcome back to the workshop, but also thank you so much for taking your time to join me. Now you might remember a little while ago I posted a short little teaser about the QTC system or spindle system solution that I use from TeknoMotor. And I happen to have a job that I have to manufacture a couple of 15mm components, and I thought this might just be that perfect opportunity to take you along and to show you exactly how that works. Now I'm going to split this topic into two videos. This being the first, we're going to briefly talk about MTC or Manual Tool Change, its benefits and its drawbacks, how it compares to the QTC, and then we're going to talk about what you see on the table. The second video, we're going to do the practical. We're going to load the file into CNC. We're going to do the tool offsets, do the probing. We're going to do tool changes, do the machining, and by the end of video 2, you would have seen a typical workflow and what's involved with the QTC system. Now, just a bit of housekeeping. You might hear me talk interchangeably of MTC or Manual Tool Change and QTC and Quick Tool Change. I don't want you to get confused. I'm just going to refer to either of those full names. Another thing is, I'm not going to cut this video anyway. What you see with me is what you get. I want to be my authentic self, and this is just the way it's going to be. The mistakes I make, I don't care about that. For me, it's more important to get a video out than to go and fix my mistakes afterwards. What I forget in the first video, forget to say, or important things, I will mention in the second video. Then the last three things that I assume you know. The first is that you have to home your machine. Mine is set up, or my system is set up in such a way that I can't do anything bar jog. If I hit cycle start, I get a prompt that you haven't homed your machine. Now I actually like the safety feature because we humans tend to forget very important things from time to time. The second thing is that you know that, and this is a free access machine, that these machines work on an axis basis or at coordinates. This is a x-axis, a y-axis, and your spindle is normally your z or your z-axis. The very last thing is that you at least understand how a job offset or a work offset work. And normally you set your work offset at the top of your raw stock, your stock or your component, or even the bottom of your stock or your component. Now I know there's instances where you would have it somewhere else, but generally it is set at the top of your stock. Now that we have that out of the way, we can get to the juicy bits. Now, I think many of us have started in the manual tool change world, hobbyist, machinist, it doesn't matter. And the principle is the same, where you have a balanced lock nut, you have your collet in the middle with your tool, you screw that into the bottom of your spindle and you work away. What I personally like about manual spindles is the fact that it's easy to learn. The barrier to entry from a financial perspective is next to nothing. I mean, you can get a spindle really for nothing from our favorite place, you know where. The problem with manual tool changes is where your tool paths becomes complicated or you have many tools to work with. Then it involves probing all the time. Now, the last time I worked with a manual tool change spindle is where there was a screen set available where you had a static touch-off plate somewhere on your machine, and every time you do a tool change, after you do the tool, lock your nut in, it will come and it will probe that specific tool, obviously because it doesn't know the offset of the tool in relation to your workpiece. Now in that case, you do your work offset once, but every time that you change the tool, it has to probe your tool to know where it is in relation to your job offset. So that is a drawback. What I do like about the manual tool change world is that because there's so much more involved, you really start to think about your toolpath strategies, how you design it, where you use what tool, so you don't use tool 1, then another tool, and then tool 1 again. So you use tool 1 up until you're done with it, and then you start to use a different tool. So you just save time in the tool changes. But that is also where the QTC is completely different. Here, first of all, you work with a tool holder where your job, or not your job, your tool offset is probed into the database before you start to work. Now, while I'm on a database, I'm going to mention it now. I might mention it later. I don't know. I just don't want to forget. Whenever I have a new job that's starting, let's say this one we're going to do, and what you'll see me do is I'm going to clear my database completely. If I have 15 tools from tool 1 to tool 15 probed into my machine, I'm going to clear it completely. The reason for that is, in the past, I've started probing my tools in, let's say I got to tool 7. Now I didn't clear the database. This is now on the premise of that. I get to tool 7, I put it back, I get distracted, called somewhere else. Half an hour later, I come back. I don't know where I was, because the whole database is populated up until tool 15. Then you have to start to reprobe, rescan, reprobe your tools, either from the beginning of where you think you were. So as a rule of thumb, I think it's good practice. I always clear my database. So if I get distracted or I do something, I know I am already probed tool 7, I can go to 8. Another thing I always also do is I verify when I have a tool list. Let's say for this tool, I know we're only going to use 3 tools. When I import my tools, my job into UCCNC, I see this is tool 1, tool 3, tool 1 to tool 3. When I load my tools into my tool holder, I check as tool 1 is an 8mm. It's an 8mm in my tool list, and I put this in tool position 1. When I'm done loading these 3 tools and probing them into the database, I once again just check tool 1, yeah, it's 8mm, tool 2, yeah. So I just make sure that the tools are actually in my tool cart exactly where they need to be. Then talking about tool offsets and when you probe your tools, there might be a scenario or two. Now I've come across 2 in the past where you might have to probe your tools mid-cycle or after the fact. And I'm going to use this 2mm as an example. Let's say you've done a job, it's been running for 2 hours with a 2mm, and you break the tool. So what do? Well, it's actually quite easy. There's 2 ways that this can go. The first is you have to replace this tool in this tool holder because you don't have a spare tool holder, or you have another tool holder that you just insert your 6mm collet and your tool, and you're just going to replace that one. But now you have a problem, your tool broke. The tool that you're going to insert is not going to be of the same length, or basically your offset. So this has to be reprobed. In this system, it's actually quite easy, and this is typically what I would do. I would stop my cycle. I would jock my spindle to where it's safe. I'll take the old tool out, the broken one, and I'll insert the new one if I have a spare tool holder. I'll go to my software, I'll say probe, it'll come to my probe position, and it'll probe the new tool. And if you check in your database, let's say this is tool 10, you will see the new value for the offset of this tool is now entered into the database. You can hit apply, you can hit save, and you can, well, what I normally then do is I rewind a couple of lines to before the tool was broken, and I hit run from here, cycle start, and it machines on exactly the same plane. If you don't probe your tool, if you just replace your tool like this and you continue to work, remember this is not going to be the same height as the other tool, so you're either going to cut into your component or you're going to cut air. So you have to probe the new tool so it gets it on the same level as the other ones. Now you might have heard me talk about tool change and probing of the tools. So how does that happen? Well, it's actually quite simple. On my machine, my tool change position is around about here. And why I'm saying roundabout is because the coordinate, the X and Y value of where this is done is stored in a text file. And when you say M6T6, a tool change, it will grab that value through a script and it will jog to this position. Now, can you have it somewhere else? Well, absolutely. The reason mine is here is because I'm in front of the machine. It's easy to get to. My tool cart is to my right, so it is just convenient for me to work. You can have this location anywhere on your machine that you want, in a workable area in any case, where you want. As I said, mine is just here. The second thing you might have heard me talk about is tool probing. My tool probing, my sensor is exactly, well, roundabout here, as you'll see, we'll hear now. It's this location is like your tool change position. It's not set in stone. You can have this anywhere you want. Now, I know most people have this mounted somewhere permanently, and when they do a tool probe, the machine will just jog to that position, probe the tool, and come back. The reason for mine being here in front is the fact that I do my tool change here, and in the beginning, when I probe my tools into the database, it just comes. So the distance between these two is very close. It doesn't have to go to the back. But I also sometimes work in the front. So what I will do is, once I've probed my, let's say my 10 tools in, I'll put my probe away and my sensor away, and next time that I want to use it, I will just have to put it back in the location where the tools will be probed. One thing I do pay extreme attention to, this is much like doing the homing and cleaning the database and making sure that the correct tool is loaded and is active. Whenever I have to put this back, when I have to probe a tool mid-cycle, now obviously job's been done, I have to probe a tool that I forgot or broke. I always clean the bottom of my sensor, and I make sure I clean that, because you want that on the surface that you used to probe the first time. So once again, there's no difference. If there's a piece of chip or a swarf underneath your probe and it stands up like that, you probe now, you're going back to your job that you were just doing, you see what's going to happen. You're going to have an offset problem. So this have to be at exactly the same height as you've done before. And I guess that is what makes a static location so much better, is because you know that can never ever change. Now, just to kind of recap, it's very important to clear your database, in my view. The second thing, and the most important thing, is the tool that you're working with is the tool that is active, is the tool that's in your cart. If you do an offset with your 8mm tool, make sure that the 8mm is set and active in using CNC. You know, I've been using this spindle, QTC spindle solution since a lot of things happened in 2017, but I've used it since 2017 in bigger and smaller machines, and I found it to be extremely reliable. You know, I would not be standing, and I think by now you might have seen it, I would not be promoting something actively if I can't stand over the product. I've used this spindle, this specific spindle, I started using in 2017, then it went somewhere else and I got it back because I wanted something that goes up all the way to 24,000 RPM, especially with my single flute tools. So I got it back. This spindle has never been serviced, it's never had an issue, it just keeps on working. I'm really happy. I can recommend, if you are in the MTC world and you want to upgrade but you don't have money for ATC, a full-on ATC, this is really a great solution. Yeah, the tool holders are kind of expensive, but you know, you buy one of these every once in a while, and soon enough you're going to have 10 of these tool holders. But the efficiency that you can just far outweigh, I think, the cost for me. And now I have forgotten to talk about something, and it's the torque tool. So I'm gonna revisit this quickly. It's the torque tool. Now this is used when you lock down your tool into your spindle. Now this is a very short snout, and it locks into which looks like a brass nut. It goes into a nut. I'm going to call it brass because it's very short. One thing you have to do is when you put this in to lock it down, make sure that you just wiggle it until it's completely seated at the bottom or the back of that little nut. If you don't push it in all the way, you're going to prematurely wear this out. Now, this is a consumable, so you can replace it, and it's very simple to replace. But if you work a little bit roughly with your tool and your nut, it's not going to last as long. I replaced this one, I think, about 2 years ago. So they last very long if you take care of this specific consumable. This is just set to a very specific torque setting, and whenever you reach it, it just clicks, and you know that the tool is locked into the spindle. And a very last thing that I just thought of is, when you might have seen me in videos where I just look at my tool holder like this, and that was for a specific reason. Sometimes you're going to find that you have a very thin piece of swarf for offcut. I'm not talking about dust, I'm talking about this small little offcut sitting on the shoulder. And once you take it and you lock it into your machine, because there's a piece there, it will tend to unlock if the piece is not very big. But that small piece is going to cause off balance here. So that's basically your spindle. It's not going to be that much, but I'm trying to get the point across. It's basically going to be off balance. And you're going to hear it because this spindle spins extremely, it's very quiet. But you'll hear it vibrate when this tool holder, there's something, a piece of offcut between your shoulder here and where it butts up against the top of your spindle. Most of these things we're going to go through again when we get to the practical and the important things, and the things I can remember or things I know that I forgot, I will mention again. I just said it, but I can't say it enough. It's really, this system is, once it clicks for you, you're going to say, gosh, I should have done this long ago. The TeknoMotor is extremely reliable, and you know what, I really love using the system. It has changed the way I approach and do my work. So that's the end of this waffle. I hope that this was informative. I know the next video is going to be very interesting, where we actually go through the whole process. Once again, I really appreciate you being here with me. Thank you very much for your time, and I'll see you in the next video.